When installing a subpanel in a garage that is fed by a single branch circuit, the question of whether a ground rod is required often arises. The answer is generally yes, a ground rod will likely be necessary. The fundamental principle at play here is ensuring proper grounding for the subpanel. The National Electrical Code, or NEC, provides guidelines for grounding and bonding electrical systems to enhance safety and minimize the risk of electrical shock. In the situation of a subpanel fed by a single branch circuit, the NEC typically mandates a separate grounding electrode system. The rationale behind this requirement stems from the way the circuit is configured. Because the subpanel is supplied by a single branch circuit from the main panel, the neutral conductor is already tasked with carrying the current back to the source. In other words, the neutral conductor is serving as the current carrying return path for the 120 volts loads. If the neutral conductor were to also be used as the grounding path, it would create a potential problem. During normal operation, the neutral conductor carries current. If a fault were to occur in the subpanel or in equipment connected to it, and the fault current were to flow through the neutral conductor, this could lead to voltage on the metal parts of the equipment. This voltage, even if small, could pose a shock hazard. To prevent this, a separate grounding system is established for the subpanel. This is accomplished by installing a ground rod, which is a metal rod driven into the earth near the subpanel. The ground rod provides a direct connection to the earth, creating a low impedance path for fault current to flow back to the source. This low impedance path ensures that the overcurrent protection device, such as a circuit breaker or fuse, will trip quickly in the event of a fault, disconnecting the circuit and minimizing the risk of electrical shock. The ground rod is connected to the subpanel's grounding bus bar, which is a metal bar inside the panel specifically designed for connecting grounding conductors. Equipment grounding conductors from branch circuits within the subpanel are also connected to this grounding bus bar. This ensures that all metal parts of the electrical system are properly grounded. A single ground rod is typically sufficient for a garage subpanel. The NEC specifies the requirements for the size and installation of ground rods. Generally, the ground rod should be at least 8 feet long and made of copper or galvanized steel. It should be driven into the earth so that at least 8 feet of its length is in contact with the soil. The top of the ground rod should be flush with or below ground level. The grounding electrode conductor, which connects the ground rod to the subpanel's grounding bus bar, must be sized according to the NEC. The size of the grounding electrode conductor depends on the size of the service entrance conductors or the equivalent for a separately derived system. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. It is crucial to consult these tables to ensure that the grounding electrode conductor is properly sized. In addition to the ground rod, the subpanel must also be bonded to any metal water pipes or gas pipes that are present in the garage. Bonding is the process of connecting metal parts of the electrical system together to create an electrically conductive path. Bonding helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. The bonding conductor, which connects the subpanel to the metal water pipe or gas pipe, must also be sized according to the NEC. The size of the bonding conductor depends on the size of the service entrance conductors. Again, the NEC provides tables that specify the minimum size of the bonding conductor based on the size of the service entrance conductors. It is important to note that the NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential to consult the NEC and local electrical codes to ensure that all electrical work is performed in a safe and compliant manner. Electrical work should only be performed by qualified electricians who are familiar with the NEC and local electrical codes. Attempting to perform electrical work without proper training and knowledge can be dangerous and can lead to serious injury or even death. The installation of a ground rod for a garage subpanel is a crucial safety measure. It helps to protect people from electrical shock and ensures that the electrical system operates safely and reliably. In summary, when installing a subpanel in a garage fed by a single branch circuit, a ground rod is generally required. The ground rod provides a separate grounding path for the subpanel, preventing the neutral conductor from being used for grounding. This reduces the risk of electrical shock and ensures that the electrical system is properly grounded according to the NEC. Always consult the NEC and local electrical codes and have electrical work performed by a qualified electrician. Now let's elaborate on some specific aspects and considerations for grounding subpanels, focusing on scenarios, code references, and best practices. Firstly, we need to clarify the terminology. Grounding refers to connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding, on the other hand, refers to connecting metal parts of the electrical system together to create an electrically conductive path. Both grounding and bonding are essential for electrical safety. Secondly, we'll delve into the NEC articles relevant to grounding subpanels. Article 250 covers grounding and bonding in detail. Specific sections within Article 250 address grounding electrode systems, grounding conductor sizing, and bonding requirements. For instance, NEC 250.32 specifically addresses grounding requirements for outbuildings, which would include a detached garage. This section outlines the conditions under which a grounding electrode system, such as a ground rod, is required at the outbuilding. Thirdly, it is important to consider the size and type of grounding electrode conductor. As mentioned earlier, the size of the grounding electrode conductor is based on the size of the service entrance conductors or the equivalent for a separately derived system. NEC Table 250.66 provides guidance on the minimum size of the grounding electrode conductor for various service entrance conductor sizes. The grounding electrode conductor can be made of copper, aluminum, or copper-clad aluminum. The choice of material depends on factors such as cost, availability, and environmental conditions. Fourthly, we need to consider the installation of the ground rod itself. The ground rod should be driven into the earth so that at least 8 feet of its length is in contact with the soil. The top of the ground rod should be flush with or below ground level. If bedrock or other obstructions prevent the ground rod from being driven to a depth of 8 feet, it can be buried horizontally in a trench at least 30 inches deep. The grounding electrode conductor should be connected to the ground rod using a listed clamp or connector. The connection should be made in a manner that is protected from corrosion. Fifthly, let's examine the bonding requirements for metal water pipes and gas pipes. NEC 250.104 outlines the requirements for bonding metal water pipes and gas pipes. Metal water pipes that are in direct contact with the earth for at least 10 feet must be bonded to the grounding electrode system. Gas pipes must also be bonded to the grounding electrode system, but the bonding connection must be made upstream of any insulated joints. The bonding conductor should be sized according to NEC Table 250.102. Sixthly, we must consider the use of ground fault circuit interrupters, or GFCIs. GFCIs are required in many locations in a garage, such as receptacles serving countertops and receptacles located within 6 feet of a sink. GFCIs protect people from electrical shock by detecting small imbalances in current flow and quickly disconnecting the circuit. While GFCIs provide a high level of protection, they do not eliminate the need for proper grounding. Grounding and GFCIs work together to enhance electrical safety. Seventhly, let's discuss the inspection process. Electrical inspections are typically required for new electrical installations and for modifications to existing electrical systems. The electrical inspector will verify that the grounding and bonding system is installed correctly and that it meets the requirements of the NEC and local electrical codes. It is important to cooperate with the electrical inspector and to address any deficiencies that are identified. Eighthly, it is crucial to document the grounding system. Maintain records of the grounding system, including the location of the ground rod, the size of the grounding electrode conductor, and the bonding connections. This documentation can be helpful for future maintenance and troubleshooting. Ninthly, remember that electrical codes and regulations can vary from location to location. It is essential to consult with local electrical authorities to determine the specific requirements for grounding subpanels in your area. Local codes may be more stringent than the NEC. Tenthly, when in doubt, it is always best to consult with a qualified electrician. The electrical work can be dangerous, and it is important to have the expertise of a professional to ensure that the work is performed safely and correctly. An electrician can assess your specific situation and provide guidance on the best way to ground your subpanel. Let's examine the practical implications of the grounding requirements. Imagine a scenario where a homeowner installs a subpanel in their detached garage to power a workshop. The subpanel is fed by a single 20 amps branch circuit from the main panel in the house. Without a ground rod, the only grounding path for the subpanel would be through the neutral conductor back to the main panel. If a fault were to occur in the subpanel, such as a short circuit between a hot wire and the metal chassis of a power tool, the fault current would flow through the neutral conductor. This could cause the metal chassis of the power tool to become energized, creating a shock hazard for the homeowner. By installing a ground rod and connecting it to the subpanel's grounding busbar, a separate grounding path is created. If a fault were to occur, the fault current would flow through the grounding electrode conductor to the ground rod and back to the source. This would cause the circuit breaker to trip quickly, disconnecting the circuit and preventing the metal chassis of the power tool from becoming energized. The ground rod provides an additional layer of protection against electrical shock. Now consider a situation where the homeowner decides to run a metal water pipe to the detached garage to provide water for a sink. According to the NEC, the metal water pipe must be bonded to the grounding electrode system. This is because the metal water pipe is considered to be a potential path for ground fault current. If a fault were to occur in the subpanel, the fault current could flow through the metal water pipe back to the source. If the metal water pipe were not bonded to the grounding electrode system, it could become energized, creating a shock hazard for anyone who touched it. By bonding the metal water pipe to the grounding electrode system, the pipe is maintained at the same electrical potential as the grounding system. This prevents the pipe from becoming energized and reduces the risk of electrical shock. Proper grounding and bonding are essential for electrical safety in any electrical system, including subpanels and detached garages. By following the requirements of the NEC and local electrical codes, you can help to ensure that your electrical system is safe and reliable. Remember, if you are not comfortable performing electrical work yourself, it is always best to consult with a qualified electrician. They can assess your specific situation and provide guidance on the best way to ground your subpanel. Additionally, regular inspections of your electrical system can help to identify potential problems before they become serious hazards.